Hello, and welcome to the Hypermill 2017.1 update training videos. In this particular video, we would like to cover the new T-slot milling on 3D model toolpath. In this toolpath, you will notice that we have a T-slot specific cutter. In the contour section, we can go ahead and define a new contour. So we'll select a contour, and then we can define the top and bottom values. In this case, we don't have an open top or an open bottom, and since we're driving to the center of this T-slot, we don't need to use reverse. If we take a look at our strategy, we have options for auto climb, left or right, but in this case, we're driving to the contour because we're driving right down the center of the T-slot. If we use zigzag, we can reduce the number of rapids, but we can also use one way if necessary. Our axial infeed can be controlled using this drop down. You can see we have options for top to bottom, bottom to top, going from middle, then finishing the bottom, then the top, then starting in the middle, finishing the top, then the bottom. Auto will switch back and forth between top and then bottom. If we look at our parameters, you will notice that we can leave an allowance on the top of our T-slot, on the bottom of our T-slot. We can also define an axial step down, which is our Z-step. But we can also define a finish allowance for the top and bottom. This means that we'll use 30 thou, shown here, for our Z-step, 30 thou, but then have a 5 thou for our finish allowance bottom. You can also see I have a 5 thou for the finish allowance top. You will also notice I have options for prefer spiral and breakthrough length if necessary. I have this toolpath set to clearance distance. Let's take a look at the result. If I simulate this toolpath, you will notice that we start in the middle, and then we're going to alternate between the top and the bottom. This is because we are using the option auto. We have a couple more options. We can use the T-slot milling on 3D model for finishing. In this particular case, we selected the contour, shown here, and then defined our top and bottom values. I did go ahead and define a finish allowance on top and a finish allowance on bottom so that we get a cleaner cut on the top and bottom. We also have the option to select multiple curves in the T-slot milling on 3D model toolpath. So if I have multiple contours, I can select them in the contours tab. Here you can see the first contour. I set the top and bottom here. Second contour, top and bottom. The third contour is a little bit different. In this particular case, I drew a line right here, and I can select these three segments, one, two, and three, to define my contour. But then I defined an open top and an open bottom. This allows me to easily go ahead and machine this area but I don't have to worry about the finish options like I have shown here for finish allowance top and finish allowance bottom. Also, we do have an option for doing cutter comp with this toolpath. If we post-process this result, you will notice I have a G41 and a G40 in the toolpath. If we show this in transparent mode, you will also notice that we can do a complete spiral, shown here. This is done by using this checkbox. If we simulate the toolpath, you will notice we start in the middle, and then I'm working my way down. Then I go to the middle again and work my way up. If I choose to, I can use a different strategy, and I can machine maybe from bottom to top. If we calculate this, we can take a look at the result. Now we're machining from the bottom to the top. One of the final things that I do want to mention is that we do have an option to define multiple stepovers. If we take a look at the toolpath, you will notice that I have an option here to define a width. If I define a width, I can also define a stepover that you see here, max lateral step. The last thing that I need to cover is actually how to define the tool itself. If I go into the tool database, I can go into the Tools tab, and I can create a new tool. I give the tool its name, and then I can define the tool dimensions. Typically, the cutting length I set to the same value as my disc height. One interesting aspect of this cutter is that we can actually define an upper cutting edge and a lower cutting edge. These values can be sharp, chamfer, or radius. If we take a look at the chamfer, I can define a chamfer angle as well as a chamfer height. Or, instead of a chamfer, maybe I want to define a radius. If we take a look at what the tool looks like now, you can see at the upper cutting edge I have the chamfer defined, shown here, and in the lower cutting edge I have the radius defined, shown here. I can save the result and then create an NC tool. With that NC tool, I can define the tool number and apply a holder. I'll set the tool reach. And the last thing that we need to cover is actually in the Technology tab. You will notice that we have an option to define some reference points. Right here, under point 1, you will notice I can pick up the tip of the tool. Under point 2, I can select Disk Top for the reference point. I will save this result. If I want to use this in an actual toolpath, I can copy this down and pull the tool from the database. If I want to use a different reference point, I can click the Tour Reference Enable checkbox, and I can select whether I want tip or desktop. Thanks for watching, and have a great day.